Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This lesson is part 3 in a series of 3 videos on vector functions. It is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended to view parts 1 and 2 on vector functions prior to watching this video. In this video, we will discuss indefinite integrals of vector functions, definite integrals of vector functions, and arc length of a vector function. The indefinite integral of a vector function r equals r of t is found by integrating each component of the vector function separately. If r of t is a vector in a plane, and r of t equals x of ti plus y of tj, then the integral of r of t dt equals the integral of x of t dti plus the integral of y of t dtj. If r of t is a vector in space and equals x of ti plus y of tj plus z of tk, then the integral of r of t dt equals the integral of x of t dti plus the integral of y of t dtj plus the integral of z of t dtk. For example, find the integral of the following vector function. The integral of t squared I minus tj plus e to the tk dt. This is equal to the integral of t squared dti plus the integral of t dtj plus the integral of e to the t dtk. This equals t cubed over 3i minus t squared over 2j plus e to the tk plus c sub 1i plus c sub 2j plus c sub 3k. The definite integral of a vector function r equals r of t for a is less than or equal to t is less than or equal to b is defined similarly. If r of t is a vector in a plane and r of t equals x of ti plus y of tj, then the integral from a to b of r of t dt equals the integral from a to b of x of t dti plus the integral from a to b of y of t dtj. If r of t is a vector in space and equals x of ti plus y of tj plus z of tk, then the integral from a to b of r of t dt equals the integral from a to b of x of t dti plus the integral from a to b of y of t dtj plus the integral from a to b of z of t dtk. For example, solve the following indefinite integral. The integral from 0 to pi over 2 of cosine 3ti plus sine 2tj dt. This can be split into the integral from 0 to pi over 2 of cosine 3t dti plus the integral from 0 to pi over 2 of sine 2t dtj. Taking the integral, we get sine 3t over 3 evaluated from 0 to pi over 2i minus cosine 2t over 2 evaluated from 0 to pi over 2j. This gives us the quantity of sine 3 pi over 2 all over 3 minus sine 0 over 3 times I minus the quantity of cosine pi over 2 minus cosine 0 over 2 times j. Sine 3 pi over 2 equals negative 1, sine 0 equals 0, cosine pi equals negative 1, and cosine 0 equals 1, leading to the quantity of negative 1 over 3 minus 0 times I minus the quantity of negative 1 over 2 minus 1/2 times j. This simplifies to negative 1/3 I plus j. If a smooth curve C is traced out by a vector function r equals r of t, for a less than or equal to t is less than or equal to b, the arc length s along C from t equals a to t equals b is s equals the integral from a to b of the magnitude of r prime of t dt. For example, find the arc length of the following vector function. R of t equals ti plus 2tj plus tk from t equals 0 to t equals 1. We start with the integral for the arc length. R prime of t equals I plus 2j plus k. The magnitude of R prime of t equals the square root of 1 squared plus 2 squared plus 1 squared. This equals the square root of 6. The integral from 0 to 1 of the square root of 6 dt equals the square root of 6t evaluated from 0 to 1. This equals 1 times the square root of 6 minus 0 times the square root of 6, giving us the final answer, the square root of 6 units of length. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.